Hello, I'm Eugene Demetri, Editorial Director of Robotics 24/7, and welcome to our first Hot Seat webinar. I'd like to thank our sponsors, Gray Orange, NVIA Robotics, and Kerber Supply Chain. Before we get into advances in goods-to-person automation, here are a few housekeeping items. If you have any questions for the panelists, please submit them in the Q&A box at any time, and we'll try to get them. And if we don't get to them all, we'll do them after the presentation by email. You can also download a PDF copy of today's slides and check out the downloads related to today's topic from the resource list to the left of the slide window in the On24 interface. If you are experiencing any technical problems, please visit our webcast help guide by clicking on the help ? Icon on the bottom of the console. If slides are not advancing, press the F5 key on your keyboard to refresh your browser. We will also have a survey at the end of this presentation. Over the past year and a half, the COVID-19 pandemic has accelerated e-commerce demand and put stress on supply chains of all kinds. Goods-to-person automation is widely viewed as a solution to many problems. But what do you need to know about adding robotics and software to help your operation? To answer that, I'd like to welcome our speakers. John Seidel is Supply Chain Technology Leader at Gray Orange. Lior Elzari is co-founder and CEO of NVIA Robotics, and John Santigate is Vice President of Robotics at Kerber Supply Chain. Welcome, gentlemen.
Thank you.
John Seidel, why don't I hand things off to you? Oh, John Santigate, sorry.
Thanks, Gene. Thank you for inviting us here to talk a bit about goods-to-person robotics and some of the challenges facing the market today, and how this innovative technology is driving change and driving change into the overall market and helping organizations cope with the dynamic nature of today's supply chains. As you mentioned, my name is John Santigate. I'm the Vice President of Robotics at Kerber Supply Chain and lead our North American business unit related to helping our customers deploy autonomous mobile robotics into their warehousing operation. Before diving into a little bit about that practice, I'll tell you a little bit about who Kerber Supply Chain is. Kerber Supply Chain is the result of a series of strategic acquisitions by the Kerber Group into supply chain technology leading companies, including companies such as High Jump Software, Inconso, WMS Software, Voitech, which was a supplier of voice technology, and several others. And overall, through the acquisition and since rebranding of these organizations, we've created the organization Kerber, which is today an end-to-end supply chain execution technology organization. We have deep expertise, especially in the supply chain process area, focused on supply chain driven software, WMS, labor management, transportation management, et cetera, supply chain consultancy services. We're a leading supplier of voice technology into the warehouse. We provide autonomous mobile robotics services for organizations, traditional automation technologies as well, and all of the services and support and advisory solutions that go into helping modern organizations adapt and leverage cutting-edge supply chain technology solutions. About our autonomous mobile robotics practice, whereas many of the other solution areas have been by way of acquisition, this product area is essentially the result of identifying a market opportunity and creating a productized approach to a channel-driven strategy, meaning we don't make the robots that we deliver to the market. We partner with leading robotic vendors that allows us to have a portfolio of solutions that really addresses all of the various mobility and material handling needs in the supply chain. And we base all of this around the first pillar there on the left-hand graphic, decision support. So we help our customers identify what would be a best fit mobile robotics solution for their operation by looking at a broad range of robotic technologies that exist in the market. And through our partnerships, we have the ability to sell these technologies. We provide integration and implementation services, post-sale support, and then one of the most exciting aspects is the element at the bottom of that graphic on the left, software development. Ultimately, what we do is we work with our channel partners to create innovative new solutions revolving around autonomous mobile robots. And so by tying all of this together, being able to help our customers identify what would be a best fit solution for their unique problem and unique circumstances, we're driving faster time to value through pre-configured integration solutions relative to our own WMS services. We're helping, again, to continue to innovate and identify new uses of this technology, and overall have the focus on helping our customers be better at what they do. I'm going to pass the baton now to John Seidel here to tell us a little bit about himself and his organization, Gray Orange.
Been around for about 11 years now. Our original automation solutions were actually sorters, and then we migrated very quickly into the world of robotics. Today, I can actually advance here. Today, we are headquartered outside of Atlanta, Georgia, in the city of Roswell. We have offices around the world. There are thousands of robots from Gray Orange in the field today. I would describe us as a robotics and software company. We're finding, to John's point, that there is an absolute imperative in the marketplace to bring together automation, both traditional automation as well as advanced automation and robotics, from a portfolio of suppliers. So we're spending a great deal of time investing in our Gray Matter software, which is a warehouse execution system for driving not only our own robotic automation, but the automation of partners and other suppliers in the space. Now, today, we're going to focus on goods to person. I just wanted to show people a couple of quick photographs so you know what we're talking about. This is our traditional goods to person robot that travels on the floor, moving the mobile storage units that you see pictured on the right, delivering the goods to the resident picker or put operator that is stationary. And this is the model that you'll see from a lot of goods to person vendors. It was originally developed and ultimately became Amazon Robotics. So it's similar capabilities, but very different strategies, different products in the market with different capabilities. And then secondarily, our most recent addition to the product portfolio in the goods to person space is a vertical AMR that is a totes to person solution. This is more designed for use in a micro fulfillment center or dark store solution where you're leveraging 15, 16, 17 feet of vertical storage capacity, but still performing the same basic goods to person model. So there are, as you explore the worlds of goods to person, not only within Gray Orange, but across the market, there are interesting use cases, interesting solution strategies out there. And with that, I'm going to turn it to Lior, who's going to talk to us about NVIA.
There, really appreciate it. So here at NVIA, I mean, we have a goods to person system, as this talk is about, but we have also various flows that we achieve with these goods to person systems. So overall, our solutions really encompass almost the whole warehouse. So we deal with, replenishment, picking, hospitals, fixing the orders in real time, all the way to pack out. So we try and manage the flow using our flow management system to go from one end to the other. And we use our robots in a pretty unique way to achieve pretty high productivities. And I'll go over that in a second. So here's a quick video of our products in action, and I'll go over the differentiation. Cool. So as you saw, our robots themselves pretty much adapt to various shelves, racking, and I'll go over how we're actually doing this in a fairly unique way to help productivity increase quite a bit. So if we look at a standard warehouse, the thing we deal with is pretty much all the random picks, right, that you have to do. And this is what our system excel at, is the random input and output that you need, especially for returns. So what we do is either overnight or during shift, we build these picker walls, as you can see here in the green, and those basically contain all the products for the current orders of the wave or the pick. And then you have people that will come in and pick from that. So it's a very dynamic picker wall. You can see that in action over here. The robots are taking those totes for those orders, bringing in. Now, this allows us to actually deal a lot with the batching aspects as well. So we can leave some of the totes longer. And you can see the person coming in and picking from those items. So you can see here is about 720 UPH. That was actually roughly about 650 lines per hour. And one of the things that we're able to do is really enhance the productivity of people by letting them burst. So as you saw from the wall, basically we build that wall and then we have somebody coming in and picking from the wall as quickly as possible. So thank you so much.
All right. Well, we'll get to our. Oh, Nir, did you want to talk about your last?
I clicked on somehow that took a while to show up.
Go ahead.
Go ahead. You can continue. Sorry, that took a while to show up.
Okay. So we'll go to the Q&A. Again, I'd like to remind the audience that there are downloads available. Also, you can enter your questions in the Q&A interface, and remember to participate in the survey at the end. But first, let's talk a little bit about the market. John Sandegate, there's been a lot of buzz around warehouse automation, but Kerber has some insight into the size of the total addressable market and what needs to be done to increase adoption of goods-to-person robotics.
Yeah, thank you, Gene. That's a good question. I know you mentioned the total addressable market. I think that's being a former industry analyst, it's a bit of a loaded question, right? The total addressable market depends on what elements you include in that figure. When we're talking about warehouse automation, the one thing that is consistent across all of the different models is that it's at a rapidly growing point in time, right? We're seeing forecasts out in 2024, 2025 of $25 billion, $27 billion, et cetera. But what they're all doing is growing at double-digit rates year over year in all of the models. And we're seeing that translate to real-world numbers as these growth figures continue to be projected forward. But when you think about the total addressable market for warehouse automation, I mean, again, it depends. Are we looking at conveyors, warehouse control software, mobile robotics, fixed arm robotics, et cetera? There's a wide degree of what you need to think about when you look at the total addressable market, right? But what we also are seeing, and I'm going to narrow the scope a little bit here and say, let's talk about autonomous mobile robots and the role in which they're playing in the market. And again, you get a bit of a variety of inputs, right? There's the goods to person type of robots that we're talking about today that shuttle racks or totes or individual units to pickers that may be stationary, or in the case as we just saw with NVIA, to forward pick locations where pickers can accelerate their picking, right? Then there's also they call them person to goods, Eugene, but I'm against that term. I prefer to call them collaborative in-aisle robotics, but CIA was already taken as a moniker, so it didn't hold any water. But those are those robots that work around in the aisles with pickers. And then there's autonomous fork trucks that exist today. And you can even classify more traditional AGVs into these categories as well. And so overall, the addressable market, again, depends on what elements of technology you want to put into that classification. But by and large, we're seeing tremendous double-digit or better growth year over year. And quite frankly, I'd still say we're at the very beginning of hockey stick growth here, moving forward globally relative to automation technologies for the warehouse.
Yeah, I had heard a figure of something like 90+% of warehouses are not automated at all yet, and so regardless of the type of automation or the process that you might want to automate, there's plenty of room. Lior,
I can add a couple of notes to that.
Oh, go ahead.
Yeah, so I think one of the other things we're seeing in this market, that the TAM is basically growing, is due to these type of autonomous robots, or basically robots are able to adapt to existing fields. And what that does is that, with low infrastructure cost, you're able to automate, and that's just basically driving adoption even more, right? So instead of, taking 2 years to deploy, now you're taking a month or 2 months at the most. And those are the things that are helping people adapt those automations, moving those quicker. So especially as, those new AMRs are coming in without any significant changes, that's the pieces I think that's also driving the adoption and driving the market to go forward.
John Seidel, one of the things that we talked about is the challenge for robotic suppliers and integrators is defining and educating the market. Where do you see that there's need for more education, and where does this growth of micro-fulfillment centers fit into this?
Yeah, so that's been a really interesting evolution for us over the course of the last 18 months or so. Initially, the early adopters of goods-to-person and AMR technology were, large retailers or wholesalers or folks with regional, national distribution centers doing large-scale implementations. But as the labor challenges persisted, as we've lived through 2020 and the pandemic and the channel shift, there's been a huge push to get product closer to consumers, to better manage customer expectations. And in order to do a more distributed node supply chain with any efficiency at all, it's really driving the automation into the micro-fulfillment center, into the dark store, or even into the store back room. And to Lior's point, the portability of goods to person as a solution strategy, as opposed to a rigid piece of automation, really creates that flexibility to react to the market, deploy the technology where it's needed, and learn and grow, right? If you need to change your strategy in terms of how you're flowing product to the end consumer, if you're getting new requirements related to same day, next day pickup or delivery, the capability to leverage this technology and put it where you need it and then evolve it is unique, I think, in the goods to person space, and certainly driving a lot of this. Now, it's all new, right? People have not done this before. So the education component of this is, helping people understand, given their business challenges, what are the use cases for advanced automation? What is the business case or the ROI on that investment? What's the time schedule duration to stand something like this up? What are the budget requirements? A lot of this market now is evolving to robots and software as a service as opposed to a capital purchase. Traditionally, a lot of the material handling equipment, the legacy material handling equipment, was a capital purchase. So teaching people about buying as a service has been interesting, in addition to just the technology.
Yeah, and speaking of software, there's been this whole discussion about the commoditization of mobile robots, which hasn't quite happened yet because obviously there's lots of different mobile robots for different purposes. But John Sanigan, can you tell us a little bit how software is becoming a differentiator? Because that's something that I'm hearing a lot, and I'm sure you are too.
Yeah, thanks. That's a great question. I mean, at the end of the day, right, mobile robots, the objective of the robot is to move something from point A to point B, right? The intelligence that directs that robot is where a lot of the added value comes into play for the market, right? I think, any one of the four of us, myself excluded, so the three of you could go into Hobby Lobby and get the components you would need to build a mobile robot, right? And in fact, Lior, you've done not quite Hobby Lobby, Lior, but obviously you know where I'm going.
Order it from
That's right. The ability to go from point A to point B is what will, at a point in time, become commoditized. The robots themselves will then rely upon a broader base of software and intelligence solutions to drive greater value. And I think, as we see, more and more visibility at the enterprise level for mobile robots and the applicability and the value proposition, there will be greater levels of investment made into the software elements to allow organizations to more quickly, A, deploy the robots and integrate them into their existing infrastructure, but B, start to create more homogeneous fleets, leveraging different robots from different vendors, different types of robots to perform different movements in the facility, and perhaps at a point in time orchestrate the distribution of the work that still resides at the top level, the WMS level, that pushes that work down into the fleet of robots. Today, there's a handful of vendors that we'll say are early stages of being able to do that, but today largely the work comes from, we'll continue to say the WMS that feeds the robot executing systems. And then the work that occurs then is sort of capsulized in the robotics solution. It's not too hard to envision a future state where that encapsulation now takes into consideration the capabilities of a broader base of solutions, and there's a third-party application that's doing the directing of that work and acting as the warehouse orchestrator, for example. And I know if you talk to, ask Lior and John, they certainly would have a perspective on that. And I think there's a perspective that the gray matter from Gray Orange is already going down that path.
In fact, John Zinal, I know that, we talked about the sort of software stack for goods-to-person on warehouse automation. Can you describe maybe some of the layers or some of the sorts of middleware that under Gray Orange that you're starting to see out in the world?
Sure. So we think of a fulfillment node as having agents in that node that are doing work. And those agents can be human beings, they can be robots, they could be legacy automation, but they are work being performed by through some mechanism. And we've taken the approach of designing our software so that we can manage those agents regardless of whether they're Gray Orange robots or someone else's robots or a human being that's interacting via traditional automation like an RF gun or something. So I think the role of the WMS is changing because of the real-time requirement to continuously optimize in real time how we're going to do e-com fulfillment based on live flow of orders into the solution. The whole notion of waiving really is going away, at least in our world, and it's much more about a continuous order streaming. And depending on the node, to John's point, I agree, in a large fulfillment center operation, we are absolutely connected to the WMS and taking work from them, not through the traditional wave, but as soon as they have access to it, and then coordinating the fulfillment. In that micro fulfillment center or store back room, there actually is no WMS involved. We're taking demand generation directly from the OMS or the ERP solution.
And you touched on something that I wanted to ask Lior about, is the role of software in maintaining the flow of products. I know that's something that you've given some thought to and written about in the past.
Yeah, so one of the things that we've done earlier on is not only provide the robots, but also provide the flow management to make sure that your orders are going out the door. And part of it actually had to do with our business model, which is a RaaS, right? Robotic as a service, where we're actually paying for that throughput. So we, as a robotics company, are sort of own that, that throughput and making sure it's always as efficient as possible. And one of the things we noticed very early on is what, both Johns, kind of alluded to, is that the coordination in the warehouse has to happen. It doesn't help you if you're picking at a very fast rate only to be bottlenecked by your pack out, or even if the replenishment didn't happen in time. So our systems today, and you can actually see that at the wall is sort of the end manifestation of that, where we're coordinating people and product at the same time to show up in real time to make sure that both people are as productive as possible and robots are as productive as possible. So overall, your productivity goes up. And to John's point about wave, that you pretty much have to go away with the wave, because the problem with the wave is that, you might be at peak efficiency at first, but as your orders starting to drop down and the waves you're picking it more and more, you're actually losing productivity or you're just having idle resources. So being able to coordinate and to manage the flow of goods is what we end up doing. So our system in ViaLogic basically manages who will do what and when, and that's from a robot point of view, right? To bringing in that tote at the time that that person is going to be there to pick it, and if there's a batching capability, right, that tote will stay in there or it will get moved to another place. And all that has to be coordinated because you don't want a person to show up, at the right minute and figure out that, yeah, the tote is not there. The robot hasn't shown up yet. So those coordinations are extremely important throughout. And we actually see them more also in older automations, where you even use a sortation device and another picking device, where if those two don't couple to each other, a lot of times you see those sorters just sitting idle, right? So that flow management really comes down to all kind of technologies, and managing that helps you increase productivity quite a bit with existing automations.
And Lior, to follow up on that point, we're talking about measuring and maintaining return on investment, right? You talk about measuring the productivity, but in goods to person systems, how do you measure productivity for both people and robots without applying the wrong expectations to either? We know that there's a pretty well-publicized case recently of a major e-commerce retailer that had difficulty because the people could not keep up with the robots at that handoff stage. What metrics do you think they should be using?
Yeah, so first off, if we look at really what people do best and what robots do best, we're really different in that. People, they are really good at bursting and doing various tasks throughout the day. If you get a person to do the same task over and over again and without bursting, right, just doing consistently, we're actually not very good at that. We're really good at doing something, and we might do it for 2-3 hours at the most, and then we get bored of that. And if you continue doing that, the productivity actually starts going down. Robots, on the other hand, are really good at doing that mundane task over and over and over again, and without complaining, without doing anything right. They will just bring that tote, the same tote, over and over and over again in there. So looking at those aspects of things, this is where, for example, we did that picker wall that allows us to capture what people do best and what robots do best. And when you measure productivity, it's not the productivity over a short time span. It's really the productivity across, let's say, that whole day. How many orders really left the door, right? It doesn't help you if a person goes out, makes a bunch of mistakes, comes back, and in the end, you only fulfilled about half the orders of what the capacity that person is probably capable of doing. And same thing with the robots, right? If the robots are picking really fast, like I mentioned, and then it gets jammed at one place because the packouts are not as good or there's too many mistakes and somebody has to go and fix it, again, that doesn't help you because the goal is how many orders are you getting out the door. So balancing it, again, kind of comes down to that flow management and deciding, which resources does best at what efficiency. And overall, from metrics point of view, we're always looking at averages and always looking at the high point, and we try to increase all of it to go as high as possible, right? So the end metric is how many orders have gone out the door during that day, right, on an average, because it doesn't help you if you did 1,000, for an hour, and then you basically for the rest of the day, wasn't picking anymore. And balancing that is a fairly complex coordination. There's a lot of moving pieces inside the warehouse, especially in an e-commerce type of application where you got a lot of randomized orders, a lot of randomized things are coming in real time, and you got to manage that. And that's really where those systems like, the ViaLogic and I think the Gray Matters, right, from Gray Orange are able to accomplish those tasks in real time. It's no longer, the responsibility of the warehouse managers to sit there and to figure out who should do what and when. It's just becoming way too complex. So by allowing the software flows, you're able to capture that ROI. But also from your question, understanding how do we measure the ROI for that particular resource, and how does that resource, behave in a particular environment? That's how it allows us to increase those ROIs in particular.
And since you mentioned Gray Orange, John Seidel, a lot of retail logistics companies over the past year have moved from pilots to deployments of goods-to-person automation. What have you been seeing?
It's interesting, right? The notion of a pilot or a proof of concept It's almost a psychological exercise because you know what? The technology works. Whether you're looking at ours or NVIDIA's or Corber's or anybody else's, the technology works. That the proof of concept or pilot program is the client becoming comfortable that it's going to work in their environment. And there are always unique components of the use case. You know, in the grocery world, it's temperature control. And how are you going to address temperature control when you can't put lithium batteries into a freezer? Well, there are very clever things going on related to, and I don't mean to go down too much a path here, but there are very clever things going on in the industry with chip-based cooling technology and being able to process goods at temperature in an ambient environment. And the robotics vendors are really driving that kind of innovative thinking. And when you're stretching the solution to meet a new use case, that's when that proof of concept or pilot seems to make a lot of sense. And it's a good way to really exercise the integration into whatever the other layers of technology that are going to be uniquely brought together at each customer to make sure that the coordination with the WMS or the other automation in the facility is really fine-tuned and working well. But once you do that, and the unit of measure should be weeks to a few months, once you do that, you should be ready to stamp these things out, because the ability to replicate this across a network of MFCs or a network of RDCs or something is very much there. And at that point, it really becomes a delivery and supply chain. And by that, I mean as vendors, our supply chain getting material to the field becomes the critical path, not the technology itself.
And speaking of, go ahead, John.
Yeah, Gene, I just add, right, we're seeing some of the same things, right? I think from the pilot perspective, the idea of running a pilot is somewhat different when I talk to customers about this sort of solutions, right? I think John hit the nail on the head. The pilot may no longer be a line or a small scale element within the facility, rather a node within the overall network. And when that site or when that location is proven out the case, then it's time to step out and scale. But the idea of the pilot has sort of, with AMRs, the goods to person specifically, is less about a smaller scale within a facility as much as it is about determining a facility and then modeling the best case solution for that particular site. Because each of the site, even at a single customer's, each of the sites may have different nuances. The modeling may be different. The product mix may be different. The velocities of the items coming off the shelves and the operating profiles may be slightly different. And there's an element of design that goes into making sure that the customer has the best fit solution for not just their operation, but each site within their operation and each workflow. But overall, the idea of the pilot has somewhat shifted when you're talking about creating a dedicated floor space, for example, in a facility to deploy a grid and put in mobile racking and robot-enabled pick station and put stations, because there's still a good degree of investment that goes into making that happen. So the idea of doing the tabletop pilots it's a little bit different now. It's more of a if not a site level, at least a larger scale pilot, because in order to show the ROI, there needs to be a degree of volume that gets thrown at these systems, right? It's not like it can be such a small scale solution. You may have not be able to provide the degree of ROI in that instance if it's too small of a solution, versus if you're willing to put in the effort to assess a fitness at a site level scale.
Well, I know that Körber works with multiple robotics vendors at different sites. That brings us to the point of interoperability. A number of organizations, including A3, Master Robotics, and the Robot Operations Group, are working on interoperability. John, just sort of follow up on what you were just saying, how urgent is the need, and from both Körber's point of view and the user point of view, what do they need to know? Is this something that they should be looking for standards? Is it something that they should be looking for third-party software or management? How do you manage these environments where we're starting to see multiple robots from multiple vendors?
Yeah, Gene, the great thing about standards is that there's so many to choose from, right? And oftentimes, but in this space, there really isn't. It's an interesting time. There's different ways of designing the way in which the data flows across the different types of technologies. we talked about this a little bit a little while ago, in the idea of creating heterogeneous fleets. And there are some robotics vendors that have a more diverse product mix. There are others that are more purpose-built. They're built for a very specific use case. You're absolutely right. I think we will increasingly see warehouses look for a best fit solution for a workflow as soon as the ability to efficiently execute across different technology arenas is there. And it's not just a one-way execution, right? The data has to go into directing where the work goes, but also the data about that workflow execution has to feed back into the overall architecture of the solution, the WMS in many cases. And so, no, I think that's an ongoing discussion. I can't say if the standards per se will come from a standards-based organization like A3, or if it will be more of a middleware type of a solution that figures out how to create ease of application and orchestration by creating that distribution layer, that management layer that resides in between the different execution level technologies and the higher level software architecture. Right, and I think John mentioned this. It's not just about the robots. It's about all of the elements that go into the work. It's the humans. It's how do you create an efficient or effective line across the technology that's being executed and the people that are in the operation itself. And to what Lior said, right? You want to have the people and the robots operating in sync, because once they fall out of sync, you lose efficiencies. And so that's one of those things where the standards help if you're trying to execute against a human, or again, going back to the idea of that middle layer. I'm a firm believer that in not too distant future, there will be a strong presence of middle layers that can execute across a heterogeneous fleet, and it's going to come out of need as more and more warehouses look to deploy one sort of robot to do receiving, to put away, and staging at the pallet level, another robot to do individual unit picking for e-commerce, and then another robot vendor that's executing the high velocity goods to person type of scenarios. And we'll see that become more and more frequent as the education happens and the market becomes more comfortable with this type of technology. We're still at a very early stage in the life cycle. I mean, 2 to 3% of the world's warehouses have automation technology deployed. There's a lot of upside here. And so the more facilities and individuals become comfortable with this type of solution will start to dictate the way in which the technology interacts amongst each other.
And John Snidel, I know you've mentioned that it's not just the technology, it's really the change management is often the most difficult part and the biggest challenge. Can you elaborate on that point?
Yeah, thank you. And that's exactly right, Gene. The end user training, the change management, the process redesign, you're really transforming the way that these sites operate, the way that the overall supply chain is performing. It is a different set of metrics. It's a different set of KPIs. It's a different level of visibility into the fulfillment operation. So believe it or not, I bet you we put almost as much energy into end user education, and that would run from the senior executives understanding how the facility is going to operate, the operational leadership team understanding staffing and staff deployment decisions that they need to make throughout the day or the year based on seasonal variability, all the way down to the maintenance and engineering teams and what do they need to know in order to correct bot stoppage or other hardware or physical issues that may take place within the solution set. So the amount of work associated with that change management process throughout the solutioning, the development, the delivery, and then the production usage of the solution itself is continuous and significant. So we partner with our customers on that topic. We do a lot of work with third-party consulting firms, the big, both the big firms as well as the boutique supply chain consulting firms. We have collaborative relationships with them where they can augment both the process redesign, change management, program leadership kinds of activities, or we'll work with both the IT and business side of the customer's organization from a program management standpoint. And there's always a work thread for change management in any of these programs. So super important.
Lior, I know we've talked about goods-to-person systems working with other enterprise systems or automation, such as automated put walls or picking systems. Can you give an example of where that might be occurring?
Yeah, so one of the things, every time we've deployed in various, places, there's always a WMS in place that's trying to make the high-level decisions, right? So saying, hey, I got all these orders, and I have to pick them in a particular way. Now, one of the things that we've done in the past, and actually kind of talking to John's point on change management, is give them the ability to connect directly to the WMS, but be able to configure the workflow depending on the customer need, and do that fairly quickly. So this is something like our VP of operation can do by themselves without necessarily having to go through a complete redesign of the system. And really what it means is that it's saying, look, for these particular items, I need to pick them this way, and then I have to go move it to somewhere else. I'll give you a specific example. One of our customers, they do like lawnmower and lawnmower accessories. And one of the issues is that you have these engines, you have these big systems that have to be picked, and you also have these smaller systems, smaller items, right, that have to be. So you have the engines, and you have all the parts and all that stuff that have to come together. Now, those kind of operations in the past have been fairly complex and even caused a lot of delays in operations. And that's because somebody will get the engine, bring it up there, and by the time they got all the small parts, or vice versa, they might get the small parts, and you get these orders that are standing still. So one of the things that we have the ability to do is basically consolidating, right? And that comes again back to the flow of being able to say, all right, I'm going to have the picking done as efficiently and in this kind of manner on this side, and then we're going to have a different picking. For example, we're guiding forklift drivers to go out and pick the various items, but bring those at the same time and making sure that they're going onto a consolidation station to bring them together and get the order out as quickly as possible. And coordinating between all those pieces, again, that comes back to that flow management system, but it also comes down to change management, because as you're doing this, you might realize certain aspects of things. We even had one facility, we deployed all the robots, had everything, and then we noticed they had a bathroom break that somebody had to take, and they would often walk through the grid through that, right? And that's something we had to predict, because the robots themselves are planning everything, trying to make everything as fast as possible. But again, it wasn't like a big deal in the system. You go in and you say, okay, well, this route, this is a route that will get blocked every once in a while. And then the robots are able to understand that, or not the robot, it's really the systems who's then guiding the robots, right? The NVIDIA logic guiding the robots to do that, to work around that during that time, so we're not blocking. And again, it all comes down to flow, right? If there's a person standing in front of a robot blocking it, that robot is not able to do its task. That person is not doing his task. And being able to coordinate all these things, but also being able to adapt to those changes, right, in real time, and even as productions change, right? I mean, we all know about peak. Peak, there's a completely set of different ways that we're actually operating in some of the warehouses, and you're almost flipping everything into a different flow during peak than you would do normally in other aspects. And again, it's just to keep up with demand, to keep up with stuff. And that's, I think, the idea of a lot of the goods-to-person systems, right, that are coming out there, is their flexibility, the ability to handle those various flows, right? A standard flow versus peak flow. I mean, you're doing 4 or 5x throughput. There's a completely different set of rules, completely set of ballgame, but being able to address that in that same system, I think that's what the new systems are able to do.
Well, and thank you, Lior, for that. I think we'll get into the Q&A now. We have a lot of questions coming in. You can still ask in the interface. If we do not get to your question, once again, we'll email them directly to the speakers, and they'll answer it afterwards. Also, the recording of this webinar will be available afterwards through your registration and Robotics 24/7 site. So let me start here. This is a question about the training. How do you approach the client training required to effectively implement this level of automation in environments that have had very little automation in the past? Maybe John Sandygate, you might want to start with that, because you talked a moment ago about how most warehouses are not yet automated at all. How much training is involved?
Yeah, I'll jump there. Thanks, Gene. That's a good question. It's obviously, when you're deploying a new technology, there is a degree of education that needs to go into the operation. And I think there's a couple different directions we want to look about at training, right? There's when you first stand up this solution, what sort of training do you need to do to the staff that's just learning a new technology, as well as the supporting staff, the IT organization, the operations management, and how they're going to be, maintaining this technology. From what I have experienced with the mobile robots, that's the more intense part of the training. Training up the IT staff for how to work with this technology itself, training the operations staff on, redesigning certain processes, because you don't want to put automation into a manual process and expect to have tremendous output, because the manual process was designed for manual execution. So you want to have some training relative to how you use this technology. For me, the more exciting aspect of training is when you're bringing on new folks. Lear, you were just talking about peak and the importance of having different methodologies around supporting periods of peak demand. Or a lot of the drive for this technology is high turnover and lack of available resourcing. And so now when you're putting new folks into work with these systems, how does that change the way in which you do your training of your associates, right? In the past, an associate would have to learn the facility, would have to learn all of the products, where they reside. I've heard scenarios where to train for peak, a worker that's going to be on site for a 4 to 6 week period to support a very short burst of activity, the training cycle to get that person up to full productivity would take upwards of 5 weeks, right? So 5 weeks to bring this person in, onboard them, get them familiar with the processes and the warehouse layout and things of that nature. Today with robotics, you drastically reduce that. In some cases, a couple of hours, where and I'm going to make it very simple. It's not always this simple, but the robot presents you with work. The screen interface shows you where the item is to pick. You may have laser-guided systems embedded there, so you get an image on a screen that shows where the item is. You get a laser pointing to that item. You pick the item from that location, scan it, and then the system itself tells you whether you picked the right item or not. This is very specific to goods to person, where you create a stationary pick module. So you're getting that person familiar with the workflows, but it takes a lot less time than getting that person familiar with the layout of the facility, the processes, the technology. Now you're just getting them familiar with the technology itself, because the workflows become almost second nature. They're very, very intuitive and designed to accelerate the pace at which you get a new associate from, a new hire without any experience in the facility to full level productivity.
And I have a similar question for John Seidel. You talked a moment ago about this change management idea, and obviously there's the idea of customizing and how much customization is needed for goods to person systems. But there's also a question here of, is there a minimum number of goods to person robots required for a successful deployment?
Is there a minimum number? It's really dependent. So we go through an entire simulation exercise with each prospect, where we model their SKU portfolio, their item profile, the item volumes, the available square footage within whatever the node in the network is where we're talking about putting this in, the desired throughput, the amount of days on hand of inventory that they'd like to maintain in that node. All of those are levers that you can pull to determine what is the optimal design for maximizing the throughput in the available space. And I will admit, we have sites that are small, in-store, click and collect sites where the AMR is delivering the customer's order to a locker system, where we have only 2 or 3 robots in each store installation. And we have large national or regional implementations with 700 or more goods to person robots in the same site. So it's very much dependent on the use case, the available capacity, the expected outcomes. So there isn't a simple answer to that question, I guess.
No, well, again, that goes to the diversity of the environments that they're in. I have a question here for Lior. In an e-commerce environment, where order streaming from the host is the download method, how does your system build the wall for those dynamically streaming orders?
Okay, that's actually a really good question. Again, kind of comes down to the flow. So in our system, we have actually the concept of SLA as opposed to a wave, right? So normally in the past, right, you would gather all these orders together, wait to execute a wave, and then assign these orders to other people to go and execute that job. And that often took a certain amount of time, right, to complete that wave, and then you'll execute another wave, sometimes even trying to optimize having 2 waves running at the same time. Instead, in our system, what we have is you have an order and you have an SLA. So for example, a particular order that has to go UPS ground, and it could be by 7 o'clock, or if it's FedEx, it has to be done by 4 o'clock. So every order in the system has what is the goal for it to finish. Now, our system basically starts building a queue of these orders and then deciding which totes should be on the wall in order to make the person as efficient as possible, right? So that's the metric the system is driving itself. So you can think of it, what layer of totes. So ideally, right, it would be every single tote in that order will be done one after another. And that allows us to capture, in some instances, with some customers, we got close to 1,000 units per hour almost, and they're always picking up almost, in each individual tote. And that's because we're able to align every single tote, and they're coming in and picking one, and getting all that done. Now, as they're picking, if you saw in some of those videos, in real time, the robots will go in and rebuild that wall. So if there are certain orders that we know, either predicting that these will be able to, leverage because of batching, because somebody's going to order the same SKU again, or it just came in real time to that system and said, hey, you pick that, we need to pick this order. The system will automatically guide that person and say, okay, well, now pick 2 of these units instead of 1 and put them in 2 separate totes. You kind of saw that that person was picking from the wall. It was sometimes picking several units from each tote, putting it into multiple orders. So again, the goal is to try to make that person as fast as possible. And the system in real time, as orders are coming in, is basically reorganizing everything. What should be on the wall? What should be the tasks that the robots are doing? When should the people come in and pick? And how to leverage that, and how to leverage multiple to come and pick and constantly get that flow out. And that's what the system, and again, that's the flow management to enhance the overall productivity of the whole system.
And again, we talk a lot about the software as sort of the secret sauce, and the monitoring being as important as the hardware and the technology itself. This is a question I'll throw out to all 3 of you, and you can answer. A lot of people are wondering about, I'm looking here at the questions, and there's 2 or 3 about the interoperability issue. And there's concern over how do they select the right combination of robots? Will robots start to be allied based on certain aspects or pockets of automation or processes? And will they need to hire or train additional staffers to manage, in the back office, to manage these different types of robots? Let me start with you, John Sandygate.
Yeah, sure, Gene. That's an interesting question. I think that's one you and I have talked at length about on several occasions. When I look at the warehouse, the first thing to think about when looking at automation is and remember, is just because you can automate something doesn't mean that you should. There has to be a compelling reason to automate those workflows, right? There has to be an ROI or an operational requirement. And more, I'm hearing customers say, the ROI would be fantastic, but what we really need is continuity of operations. We need to automate this process because we can't complete the work that we need to complete over there. And so making investments into automation is not just being driven by ROI anymore. It's being driven by the idea of operational continuity. Now, to get direct to that question, all of the different workflows that occur within the warehouse have different opportunities, right? You're going to receive full pallets of product in inbound, and maybe you shuttle those pallets to a break bulk area, right? So if you're looking to automate, there's got to be a mechanism to move full pallets from point A to point B. And then maybe you break those pallets down into the case level, and you're going to stake those for put away in different locations. So now you need to technology capable of transporting smaller payloads to more various locations. And then in picking, are you picking at the pallet level, or are you picking at the each level or the case level? All of these different workflows may occur within the exact same warehouse, right? And so in terms of determining what is the best fit solution, it's looking at that particular workflow, looking at the material that's being moved, looking at the volume and velocity of work that exists there, and many other metrics. There's no magic bullet. It's really about doing a deep assessment of the workflows that exist and the characteristics of that particular set of work, and understanding what exists in the market to help solve those particular automation challenges.
Lior or John Seidel, either do want to comment on that?
Yeah, I can comment.
Go ahead, Lior.
Okay.
Go ahead.
Real quick, actually. So for us, the same deal, right, is with those different automations, I think is actually what John Seidel talked about before, is simulations is extremely important. So you can sort of get a head start and understand what are going to be the flows, what are going to be the bottlenecks, which automation should you use and when. So for example, we partner up with Prigis Auto Baggers. That's another robot in some sense, right? That's doing all the auto bagging and everything. But again, managing the flow and understanding how things are going to happen and how fast would a particular auto bagger work, what size, all that stuff during simulations allow you to really capture that requirement and then understand which pieces and which vendors you're going to have to contact in order to, execute that system.
I would just add, yeah, sure. I would just add a couple of things, right? As you look at different areas of, functional areas within the facility and what's going on and the potential use of automation, we're finding that the business case is different depending on what the use case is you're talking about. To John Santigate's point, we have something called Ranger Interlogistics, which is a forklift replacement. It's doing full pallet moves from point A to point B, so dock to stock, reserve to active, post-packing to shipping, et cetera. And that one is almost always justified by a lack of access to qualified forklift drivers and being able to attract and retain qualified forklift drivers and being able to maintain productivity through peak for those functions. So it's very much a labor play there where we just can't get the help that we need. In the traditional goods to person space, it's much more about facility throughput, right? So whether you're looking at the NVIA stuff, the gray orange stuff, this is all about how do I maximize the asset that is this supply chain node and get the most through this operation without having to expand my network and stand up a new distribution center. So capital deferment can be a big bonus there, as well as labor productivity. So it really varies from one use case to the next. And it's extremely common that our robots are cohabitating in the same building as somebody else's robots, right? We have a mobile sortation solution that we use as a takeaway device for an auto store instance. We have, it's very common, and any of the vendors should be able to work with a customer to think through how are you going to leverage these different use cases that run up against each other if the appropriate automation comes from different suppliers. And of course, there are consultants that make a living doing that as well. But we typically start that journey with a warehouse automation assessment, and there are going to be business challenges inside that site where the answer from Gray Orange is going to be, you're right, that should be automated. But that's not us. You should go talk to NVIA, or you should go talk to whoever, right? Because we each have things that we do really well, and the market is driving us to figure out how to do these things really well together. So we're going there anyway, so just ask.
Well, and I think that's a great note to end on. So thank you. I'd like to thank all of our expert speakers, John Seidel, Lior Ilzari, and John Santigate. Thanks again, gentlemen, for sharing your thoughts and insights.
Thank you, guys. Thank you, Eugene. Thank you, John. John. Great.
Yeah, thanks, guys. Thanks for having us.
I'd also like to thank our sponsors, Gray Orange, NVIA Robotics, and Kerber Supply Chain. Remember to download the free resources, check out the survey, and note that there will be a recording of this webinar available probably starting tomorrow. Remember to visit Robotics 24/7 for the latest developments in practical automation. Subscribe to our newsletters and register for our next free webinar on collaborative robots in September. Until then, I'm Gene Demetri, Editorial Director of Robotics 24/7. Thank you for joining us.